right, hi there. This little video, if you missed class today, is about solving and graphing inequalities. Solve and graph inequalities. So the other day, just to really quickly recap, we did things like if x is greater than 6. We just took and graphed that on a number line. And so, again, really quick, remember that if we have a less than or a greater than, that these things get an open dot. And if we have a less than, that's a greater than or equal to, greater than or equal to, or less than or equal to, then these get a closed dot. Right? So we have an x is greater than 6. And so this guy, this symbol here, gets a open dot from right here. So we put an open dot at 6. And if x is bigger than 6, then we would shade everything that way. And that would look something like that. Well, today we're actually solving and graphing inequalities. So you should have a worksheet that goes along with this. And I'm going to do problems number 2 and 8, and then another example from those. So let's do number 2 first, and that's right here. Negative 15 plus b is greater than or equal to 2. So I'm just going to rewrite that. Negative 15 plus b is greater than or equal to 2. So we're going to solve this like we would solve for b, or x, solve for the variable. Like you would an equation with an equal sign in it, right? So we're going to want to isolate the variable, get it by itself, get the variable by itself. And here we can do that by keeping this b. We want to kind of lock this here by itself. So we're going to move this 15 away from it, and it's subtracted. So we're going to add a 15 to both sides. That's going to cancel a 15 out of here, but the b is going to stay. We bring down the inequality symbol, and we get 17. So b is greater than or equal to 17. And then we're going to graph that. So we're going to solve it and then graph. Okay. So we're going to graph b is greater than or equal to 17. So this guy gets a closed dot. So we're going to put that at that value of 17. And then because b is bigger than that value, we're going to shade everything to the right of that value. Okay, and you should shade everything to the right, including the arrow, because it goes forever and ever and ever. All right, I'm going to add a screen and an example problem. And this one looks like negative 5x is less than 125. Well, if that was an equal sign in there, all we would do here is divide this by a negative 5, right, to solve this. But here's where some alarm bells in your head need to go off. If we divide by a negative, or multiply actually, if we divide or multiply by a negative, then the inequality symbol flips. Okay, so this is a big deal. So when you divide by a negative, this guy is going to flip around in the next step. Okay, and I do that. I circle it and I write that it's going to drop and flip. So if it was pointing left, now it's going to point to the right. Okay, that's what I mean by flipping it. Here it's pointing left, here it's pointing right. Okay, it's going from a less than to a greater than. So what happened? My negatives cancel out and I get an x. 125 divided by negative 5 is a negative 25. And then we would graph that thing on a number line. I just plot my negative 25 in the middle. Negative 24, negative 23. That's enough to give us an idea. Negative 26, negative 27. And x is greater than, so that would be an open dot. Negative 25. And greater than is always going to the right on the number line. Okay? And then the last one I want to do with you, it might make you flip out a little bit because there's fractions. Looks like this. It's number 8. I'm going to move it up the screen just a teeny bit. Okay, so we're going to write this just a little bit different than the way it looks on the paper. Right now it looks like this. Negative 3 is less than x over 7. Here's how I want you to write it. I want you to write it. Negative 3 is less than 1/7 x. Okay? Now, what we're going to do, if you have a fraction in here and that fraction is only in the denominator, we can get rid of it by multiplying it out, right? So you can multiply both sides of the problem by the denominator. All right, so what I'm going to do here is multiply by 7 and multiply by 7. That means this guy will cancel this guy, leaving me just an x. And 7 times negative 3 is negative 21. Now, I mentioned before this x being on the right-hand side. It's often useful if you switch these. Oops, switch. So the x is on the left and the number's on the right. But when you do that, you got to switch the sign again, right? Because the big part of the symbol, see how this is wider over here and the little point is by the 21? You got to keep it that way. So the wide part is by the x and the point is by the 21. So this is really x is greater than 21, x is greater than 21. It reads the same both directions. Okay? So that would be the answer. And then if x is greater than 21, that's an open dot. It would go on negative 21, would be right between negative 20 and negative 22. So that would be right here. And then greater than would be this way. Okay, so you don't have to write this 1/7 here, you know, kind of going back to this side over here. If you want to just multiply by 7 and multiply by 7, right, you can maybe see that easier. X is greater than negative 21, whichever is easier for you. I think you're going to have to deal with the fractions. They're not going to go away. So, but those are it. That's it for today. Okay? Hope you were here in class and you got these notes. Toodaloo.